Have you ever been working on something critical only to be hit with a session limit? Has one complex query eaten up over half of your session duration? These situations are not only a break in productivity, but they are literally a vibe code killer. In this video, we'll show you how to self-host LLM models and keep the vibe alive. Hi everyone, my name is Rob from RobOps, and today we're going to be talking about self-hosting LLMs with Ollama, running a model locally on your own hardware, calling it from anywhere on your network. No API key required. In this video, we'll be self-hosting an LLM model using Ollama. Ollama is an open source tool that lets you pull, run, and serve large language models on your own machine. At a high level, it handles everything you'd normally get from a hosted API, such as model management, REST endpoints, and streaming responses, except the model runs on the hardware that you control. So why would you self-host in the first place? The biggest reason is cost and rate limits. Frontier model APIs like Claude and GPT bill per token and enforce rate limits on sessions. For exploratory work, automation pipelines, or anything that requires high request volumes, those constraints become real blockers. A local model has no per token cost and no rate limiting, so you're only bound by your hardware. The second reason is data privacy. Every prompt you send to a hosted API leaves your machine. For internal tooling, sensitive documents, or anything that you'd rather not send to a third-party endpoint, a local model keeps everything within your network. And finally, local models have gotten genuinely pretty good. Models like Llama 3.2 and the Qwen series are not frontier models. They won't match GPT or Claude quality for complex reasoning, but for summarization, code completion, and writing assistance, they're pretty good. Knowing when to reach for a local model versus a hosted one is a skill in itself, and we'll see the limitations when we actually host one live. So for today's experiment, we're going to be running a local model, Qwen, using Ollama on our PC. Then we're going to expose that model to our local network, and then we will attempt to call that model from our MacBook, which is our dev workstation, and we're going to see how we can basically leverage a model that's running on my PC to create a similar Claude code experience, except we're going to be using local models instead of the default frontier models. So with that said, let's jump over to our PC. Okay, so here we are on our desktop, and we're at ollama.com, and what we're going to want to do is just effectively download the client. And so here you go download. We're on Windows machine right now, so we're going to click Windows. And once that downloads, you will be able to open it up. And once you're up and running, you should see something similar to the UI on the left. And this is where our Ollama is running. And as you can see, you can go to launch, and you can launch several different like LLM experiences using OpenClaw, Claude, Codex, etc. And we can also create new chats, and we can select the models that we're going to be using. Now, as you can see, there's a bunch that require it to be downloaded, and so that's what we're going to do in the next step. We're going to actually download the model, and for this video, we're going to use Qwen 3, the 4 billion context model. And the reason we're using 4 billion is just because it is appropriately sized to run on the hardware that I currently have available on my laptop. As you can see, they're up to 30 billion context window, which will make the model a lot more effective, more context window, more things to reference. But unfortunately, my current computer will not be able to run those successfully. And so what I found most effective is the 4 billion context window. So what we're going to do is we're going to pull that model, and we are going to show how to do that. And so the best way to do that is just open a PowerShell as an administrator. And effectively what we're going to do is, like very similar to a Docker image, we're just going to run an Ollama command called Ollama pull, and then our model name. And so if I go here, Ollama pull Qwen 3, 4 billion context, as you can see, very similar to how it's listed there. And what this is going to do is it's going to pull the model and download it to our machine. And now that our model is finished, we're going to simply run the model we just downloaded. And so a very similar command, Ollama run model name. And so here it's going to calibrate the model, and I'm going to just pull down the UI just to show our system memory to see how the model running locally will affect our hardware. And so as you can see, we have it up and running. And so if I can just give a simple prompt to say something to the effect of, what is Kubernetes? It'll now think, and in a very similar way to other models, it will generate a response. And on the performance side, you can see our GPU memory usage spiked up the 6 gigs, and we get a response fairly quickly. And so as you can see, the terminal experience will work as you would typically expect, but we also have the Ollama UI. And so if I click the Qwen 3 4 billion context window, I can say, hello, what is Kubernetes? And you can see it will do the very same thing, except in a UI that is a similar experience to your default like ChatGPT experience. And so this is great. We have a model that's running locally. And what now we are going to do is open up this connectivity over our local network and allow us to access this model from our MacBook on the same network. So the first thing we're going to need to do is expose the Ollama host on port 1143.4. And so what that's going to do is it's just going to open up that port and serve our Ollama host. And what we're going to do is run this set environment variable command to say set environment variable on localhost for user. And I'll click enter, and that's going to configure the environment variable. Now, the next thing we're going to do is actually open up our firewall to allow communication on this local port. A few important caveats here. If your router is port forwarding your 1143.40 host to the internet, then this could effectively expose your local network to the public. That's typically not what happens, but it is an important caveat and something that we're going to prevent by specifically adding a remote address for our laptop. So if you look at this new command we're going to put into here, which is going to augment the firewall rule, we're effectively going to say new firewall rule inbound on 1143.4, and we're going to add a remote address, which is the IP address of our laptop. And so we're going to click enter, and this is going to update the firewall rule, and it's going to open up the connection only for our laptop so that we can communicate with this model over our local area network, but only from our laptop. So if you're on a network that you share with other people, this is probably a good idea, because if you're just testing and you have things like roommates or people that you live with, you probably just don't want this floating on your local network unauthenticated. So this locks it down to just your laptop for experiments, and we can hop back over to our laptop and test the connectivity. Okay, so we're back in our Mac environment, and I have a simple README open, and we are actually going to test how we can call our local model here. And so we're simply going to curl the IP address of our PC at the API generate endpoint on port 1143.4, which is where Ollama is running and serving our model. And we'll specify Qwen, and we'll summarize. And so if we go here into our terminal and we click enter, this will pull the data from our PC, send in the prompt, which is just summarize what Kubernetes is in 2 sentences, and it will stream it back to us. And we'll notice that the output of this is not something that's super human readable, and that's why applications like Ollama exist to help us kind of like parse the streaming data from the LLM and present it in a way that we can understand. And as you can see, here's the streamed results, which, like I mentioned, not necessarily super human readable. So now that we're in the code view, we're going to simply set up our Ollama host to point to our locally running model and call Ollama. And here we can see a bunch of different options that are available to us using the model that we reference. And so in this example, I'm going to say launch Claude Code. And what we're going to do is choose our model, Qwen 3.4b. And this should leverage our local model. And so as you can see, we have Qwen 3 4b context. And if I say something to the effect of explain to me what Kubernetes is in 2 sentences, we should be able to leverage our locally running model in Claude Code, in the Claude Code interface, to serve this request in human readable language. And as you can see, we are unraveling the results, and it's going to give me an explanation, hopefully, about what Kubernetes is. And there we go. Kubernetes is an open source container orchestration platform that automates the deployment, yada, yada, yada. Sounds right. Now, as you can see, this is something that is able to answer simple requests for us. But if I say something to the effect of create for me a simple Next.js application with all of the defaults. Now, if I do something more complicated, it's obviously going to take more time, but it's also not going to have the same level of quality in its response. And so we can see what it'll come back with a simple ask, which is just create a boilerplate front end using Next.js. And so jumping back right into the response, we can see that it's a little bit confused because there's a lot of context, I guess, adjacent to it around Godot, which is the game development that we're doing, and I have a Discord plugin. So it's looking through some of these things, but it doesn't find anything. And so it's saying, hey, you need to run npx create next app, which is actually correct. But it's not actually like going forward and recommending it in a similar fashion that it would if you were in a model like Opus or some of the later GPT models. So we're going to pop back over to the slides and we're going to go over the limitations of this approach and wrap up. Ollama is a genuinely useful tool, but there are 3 things worth being honest about before you build around it. First, local models don't match frontier models on complex tasks. Our Qwen model is fast and capable for structured tasks and straightforward generation, but as we asked it more complex multi-step code writing questions, it is not able to handle ambiguous instructions well. And you'll feel the gap with a frontier model like Claude or GPT. Know which tasks are good enough for it and reach for a hosted model when the quality actually matters. Second, your hardware determines your experience. If you're running these things on Silicon or M4 products, you will be able to run around 7 to 8 billion parameter models. The PC that I'm running on is about a mid-tier PC and it's running on a 4 billion. But if you have an upper end PC with a better GPU and a lot of RAM, you can start to touch on those 30 billion context window models. But that being said, it will feel different on different machines and you are limited by the hardware that you own. Third, there's no authentication on Ollama endpoints by default, so keeping it on the LAN is fine for us, and we ended up actually locking it down a bit further, but that doesn't make it unsafe for internal use. It just means the security boundary is your network, not the application. So like I said, it is a good alternative if you are running up against your Claude and Codex limits. However, it does have its limitations, and I would say they do very well for those things that are easy, and use your quotas and your session durations for those complex tasks. And with that said, I want to say thank you for watching. I hope you learned something today, and I hope that you go and try this out. It is interesting, and there's so many open source models that you can choose from that specialize in different things. So like I mentioned, thanks for watching, and I hope you have a great week.